Okay, to begin with, today is basically a Heaven Sent review day and therefore shouldn't be as tough. I'd like you to start by looking at this. Basically what it's asking you to do is stick in those numbers 0, 1, 5, and 1/5 into the function. Let's see what you get. This is what you would do if you were graphing it. You'd be finding points. If x is 0, what do you get? If x is 1, what do you get? All right, so if you haven't already, do that warm up. It's going to be quick. I'll give you a second. Okay, but even better than no solution is when you have a 0 here, it's the asymptote. Good. Add x equals 0.
The second one, I got 0.
You stick in a 1 right there, you won the argument. If you got a 1 in the argument, you get 0. You are correct. How about f of 5?
1.
Log base 5 of 5 is 1. And the last one.
-1.
Because that 1/5 could be written as 5 to the -1. And then you've got a base that's the same, and the power is -1, -1. The lady find you in the hall or no?
I went to the office and they told me to go to the port to look for it. I was double checking
Go
it.
look on your desk.
Was it my bag?
No.
The lady came in here and delivered it. She looked you up, figured out what class you had, brought it here. So, all right, so try to find, we're on page 2 of the notes now. It looks like this. We practiced this a fair amount, but hey, I think we should practice it again. Where's the asymptote on this first one? I'm on. Hint has to do with that inside here.
-3?
It is. Everybody did put a dotted line at -3. Charlotte, give me one way to graph this thing. Yep. That's probably the best way. Val, give me a point that's on it. You get to pick what to put in for x, so choose wisely. I agree. Because then you get 2 plus 3 is 5 in there. And so then log base 5 of 5. Val?
1.
Yep. So 2 comma 1 is on your graph. Now 1 point enough to graph this thing? No. You're going to need 3 points at least. Taddy, give me another point.
You just do 1 on one.
Okay. Sure. Then you got log base 5 of 4. How do you like your choice now? Okay, so pick something different than 1 so that it'll work nice. Log base 5 of... What would work nice here, Jack? Like, wouldn't it be nice if that was, I don't know, 25? Or wouldn't it be nice if that was 1? Or wouldn't it be nice if... So think that way.
22.
Okay, 22 works. Now, I have a little problem with that, and it's going to be really hard to graph. But it's all right. We'll put in 22. And then, what's the answer? It would be. And even if you don't, if it doesn't fit on the graph, at least you know, okay, it goes from 2 comma 1 to 22 comma 2. That means it's only rising a little tiny bit over a long period of time. How about the y-intercept? Wouldn't that be smart? Okay. Etta, how do you find the y-intercept?
-2.
All right. If I put a -2 in, then this part becomes 1, and then you've won the argument, and if you have a 1 in the argument, you get 0. -2, 0.
Would that be the x-intercept?
Sorry, that is the x-intercept, but it's still a good point, and it's important. Okay, how about the y-intercept? Finish this sentence, Jack. The y-intercept is where...
X equals 0.
Okay, so if you put in a 0, the icky part is... What, Jack, what's the icky part? If I put in a 0.
It didn't, like, work out as nice.
Yeah. Would you agree that we could at least know that log base 5 of 3 is like something where 5 to the x has to equal 3, and therefore it's got to be less than 1? 5 to the 1 would be 5, so that's obviously too big. So something less than 1. So forget if I just put a dot in here that's kind of between the other dots. It's got the right idea. And then can you tell where it's going to go? I can tell where it's going to go. Really, really, really close, but never touch the asymptotes. Asymptotic behavior. Kind of just sucks into that asymptote from there on. Okay, cool. Would I have gotten credit for this? I have 3 points. And I've got the asymptote on here. Yeah, I would have gotten credit for that.
So you still have to draw the line though, right?
I did.
Okay.
Yep.
I just want to make.
You're right. No, you can't just put dots. You have to connect them with a line. That shows me mostly whether you know that it gets closer and closer to the asymptote. Like whether you know how the graph goes when it comes to asymptotic behavior. Okay, so anyway, let's go to this one. Okay. Give me a point on it, please. Jacob. Slide this under your desk.
Negative 3, 0.
Neg-
0, negative 3.
0, negative 3. I agree with that. I put a 0 here. Anything to 0 power is 1. 1 minus 4, negative 3. I agree. 0, negative 3. Okay. Would it be smart to put in the asymptote? Yes. Would you agree on an exponential that they generally look like this and their asymptote is generally there? Okay, but where's this one moved? Down 4. So do you get that asymptote is going to be moved down 4? Okay, so that would be really smart for you to start that way and put in the asymptote. You can't just get the asymptote by like sticking in a number. On the other kind you can, but so it's good to know that it's not going to go below that line. And it's generally rising on the right. Can you tell me another point? Okay, I put in a 2. I get 2 to the second is 4. 4 minus 4 is 0. 2, 0 for sure works. Is 2 points enough to tell which way the curve's going? No. Isaac, give me another point.
3, 4.
3. 2 to the third is 8. 8 minus 4 is 4. 3, 4 works. Now I can start to kind of tell the direction of the curve, and it matches what I was kind of drawing out before, which is that they generally look like that. That would have given full credit. Got 3 points, got the asymptote. Okay, would the ones on the test be harder than that? Probably, because these are just like baby numbers, okay? How would we make it harder? Well, we might have, like, had a 1/2 instead of a 2. Or we might have put like 3 times in front of it. So make all the numbers a little bigger. Or anyway, this might have had a negative out in front of it. Or it might have had a negative 2 out in front of it, which just means you'd multiply everything by negative 2, that all the y values. But okay, go on to this page. You have to know all these properties. I'm going to do an example problem in every category, okay? So, here we go. In this first category, here's an example problem. I give you log base 3 of x plus log base 3 of 12, and I say it equals 1, and you'd have to solve. Those both have log base 3. I've got the answer already. They're not that hard if you know what you're doing. Okay, what's the key? The key is to condense these two into one log. Charlotte, what log do I get when I condense those two?
Log base 3 of 12 times x.
Of 12x equals 1. And then Whenever you kind of get stuck, Max, what do you do when you get stuck in this unit?
Factor it.
Yeah, this one won't factor. Clear fractions, this one doesn't have fractions to clear. So in this unit specifically, everybody pay attention. You rewrite. So how do I rewrite this one, Max?
Log of 3. Wait, no, log base 3.
Nope, it's already a log. You want to rewrite it into that other form.
Oh, okay. 12x equals 3.
3 to the 1 equals 12x, just like you said, just backwards. Notice, no more log. All right. Know how to finish this one, Amelia? Don't overthink this. I'm almost done. You're just solving that.
Oh, okay.
Divide by 12.
Mm-hmm. So simplify the answer as what?
1/4.
There it is. That's the answer to that one. Any questions about how we did that? Did anybody get to 1/4 before I said it? Okay, good. All right, this next one, how is it any different at all? It's got a minus instead of a plus, and that means that you're going to divide. Okay, so let's try one of those. Log base E. What else could I have written that would have meant the same thing? ln. Log base E of 4 minus log base E of x is equal to log base E of, let me think, 2. That's maybe the first time we've done one like this, so don't feel too bad if you get stuck in a minute. Like, you should feel bad if you don't know anything of what to do, because like that's what we learned yesterday. You're supposed to know that that can go together, so Nola, tell me what we get there.
Log base E of 4x.
ln, or I'm going to say log base E, because it is better, honestly, because people oftentimes will not see stuff that the base is involved in unless you write the base, equals log base E of 2. And this is the part where you may not have ever seen this before, and therefore don't feel too bad. But when they have the same exact base and there's one log on each side, just like this, a log equals a log. Uh-oh, something's wrong. Yes? Yep, she made that easy mistake of, oops, this is a subtract, and so therefore it should be a divided by x. Okay, now that we're down to one log on each side, I was already leaning into this. That can cancel that.
Oh,
Isn't that handy? So if you have the exact same log with the exact same base on both sides, they can cancel. Question, comment?
Is there another way you could do it, like, since
There's always more than one way you could do it. Yes.
if you put it into exponential form, you'd have.
But stop. I agree there's another way to do it, but we need to finish this way, okay? So I'm almost done. Yeah, I'm not just in your way. I'm just saying I don't want to go into the other way until I finish this way. All right, so what just happened there? When you have a log of the same base on both sides, they can cancel like this. Technically, they aren't canceling, but boy, it's nice to just cross them off. Technically, what's happening is this just has to equal that. So 4 over x must equal the other thing. If I give you the simplest example, if I just said log base 2 of x equals log base 2 of 5, just think about it. Wouldn't that have to be equal to each other? Log base 2 of something has to be log base 2 of, well, those have to be equal, right? Now, I say often that these cancel, even though they don't really cancel, technically. It's just that this equals that. So you don't have to cross them off. You can just write it down as, 5 equals x, or x equals 5. And you don't need to show the canceling. I'm just being picky here because somebody might say, they don't cancel. Technically, they don't. But the red things are equal. Okay, so then I just have to finish. I multiply both sides by x because I want to clear the fractions. You remember that? Clear the fractions. Second rule of pre-calc. All right, so then that brings me down to 4 equals 2x, and then I'm pretty much done. Divide both sides by 2, and I get x equals 4 over 2, which is x equals 2. Yay. Yes?
Can you cover like the exponential way?
Okay. Jack, take it away. What's another way we could have done it, and where did you start that way? Like, when I was here, were you there also, or did you do it different even earlier than that?
Once I had divided, so I had the log base e of 4 over x, there's log base e of 2.
Okay, so you got this far,
Yep.
but then you didn't cancel them, right?
Yeah, I took e to the power, so I did the circle thing.
Yep, the circle thing where you start with e as your base, and you're doing a rewrite
To the
and
power
saying
of
e to the power of
log e2.
log base e of 2, and then keep the circle going,
And then that equals 4 over x.
and that equals 4 over x.
And since there's the same base, you can cancel the 2 e's, and then you're just left with 2.
And that equals 2. And you'd get the same exact answer at the end. Multiply both sides by x. 2x equals 4. X must equal 2. Cool. Yes?
Why does the e to the log of e of 2, how come it counts?
Same bases.
He's right. All right. So, if you didn't know this pattern, right here, I'm circling it. It's really important to know this one. In fact, I said this was the most important thing in the patterns, is if the bases are the same, the answer's already there. That's the base, which has a power of log base e, and that's the base of the log. So those two e's are both bases. If the bases are the same, then the answer's already there. All right. In fact, we can show you where that one is. It's one of our, it's right there. It's number 8. Take a look at number 8. See how the A and the A are both bases? One's the base because it has a power of log something, and the other's a base because it's the base within that log. Those A's are the bases. The bases are the same. The answer is X. Okay. So, down to this one. Here's an example of that question. And somebody says, you can condense that more. And you're like, I don't have any idea how to condense that more. Then you have to use the power rule, which is that this 3 here can go up there, and now it's not there anymore. Just knowing that that's something you can do is important. And if you wonder why, if I said log base 2 of 2 to the 5th, would you agree that the answer to that is 5? Would you agree if I move this 5 here, the answer will still be 5? Make sense? So you can do that. It's called the power rule. If there's a power here, it can go here instead. All right, next kind of question I'd like to practice is called condensing. No, sorry, expanding. Log base, no base, weird, but happens all the time, of 100 over x squared. That can be stretched out and made into 2 logs, and expanded much further than it is right now. This is the condensed form. So, expand it all the way. And the directions are always expand and simplify, which means if at any point you get something like log base 2 of 2, you got to make it into a 1. You got to simplify it down. So you expand it, but you also simplify it. Yes?
Just wondering, if you had like log.
I'm going to pause for a second. All right, so here's what you should have done here. You should have known that's 2 logs. That's log. And I think it's always smart to put the base in. If there isn't a base, still put the base. Log base 10 of 100. And why? Because a kid who just writes log 100 is probably not even going to notice that, oh, wait a minute, this and this can probably be simplified a little bit because I could make that into a 10 squared, couldn't I? See, if you have the base there, you're more likely to notice that. Plus log base 10, always write the base, even if you don't have to. Hold on, I'm not done yet. Of x squared. And yep, you're right. This is a minus. So often easy to forget the plus and the minus. Mess those up. And is it expanded all the way? No. Is it simplified all the way? No. If you got this far, that's a good start. But you didn't expand all the way and you didn't simplify all the way. So this 2, how many of you caught that the 2 needs to go down in front? Raise your hand if you did. Ah, some of you maybe not know that that's considered more expanded. The only way I would give you that would tell you that it's more expanded, would you agree that this is an exponent, which is like superscript, which means the numbers are smaller? And when you put the number in front, it's bigger? That's a way to remember that that's considered to be more expanded. I know, that's kind of lame, but I do need to prepare you that that's considered expanded, and the other spot, putting it here, is not expanded. Okay, and then this 100 could be like 10 squared, and then do you get, I've got a 10 and a 10, and the bases are the same, so the answer is just 2. 2 minus 2 log. Do you have to write 10 right there? No, but it's smart. Base 10 of x. Again, you could have just said log x, but whenever you do that, you're saying there's no chance that it can simplify further. Put the base in. All right, any questions about that kind? I'm going to give you one more like that. Log base e, I know and you know what that means, I hope, of e to the third over x. Expand and simplify. So I can imagine a kid getting it this far and forgetting to do anything else. I could also see a kid putting the 3 in front and then thinking they were done. That's equal to 1. So therefore, it's just 3 times 1 is 3 minus log base e. Could you write ln? Yes. Of x. Raise your hand if you had that one right. Okay, cool. All right. So here are some that we're going to focus on for a moment. When these two are the same, the answer is the exponent right there. When you've won the argument, you get nothing. Bases are the same, answer's already there. This one's the power rule again, which basically means that m can go to the front. Any questions on any of those? If you get those, then these should be pretty easy. Pause for a second, where you give A, B, and C a try. C might stretch you, but C is typical of the test. Okay, so the first one is just like a no-brainer. Oh, those two are the same. The answer is 144. Raise your hand if you had that one right. Good. The next one, it's all of a sudden like, wait a minute, those aren't the same. What the heck am I going to do with that? All right. These aren't the same. You're right. There is definitely more than one way to handle this problem, but here's how a tool I want to make sure you have in your bag of tools. Set it equal to X. And then rewrite it. Remember, when you get stuck, rewrite. 9 to the X equals log base 3 of 20. Okay, so a student said, couldn't we just take this 9 here and make it into 3 squared, which is interesting. I'm not sure I like your final answer that the answer is 20, but I like that idea.
No, the answer is 400.
Oh, so what did you do from here to make this work?
You move that 2.
Ooh, I like it. Because you get how these would be multiplied together. And that 2 is in front of that log. So therefore, it can go up as a power on this 20. Nice job. So that one's, now we got base is the same. 2's not here anymore in the way. And it's 20 squared is 400. Boom, nice job. Had the teacher stumped. Kid figured it out. Nice work. Okay, how about this one? Let's give some people time to work on this. I've got it now. Okay. Did anybody have any little, just not the whole answer, but a little breakthrough that you think might help people a lot? Check. Just a little breakthrough, not the answer.
Since the second log, the 2 log,
That little 2, is that going to be the key?
no, but since it's a common log, it's 10 there, so the common is the same base.
I agree. That is a really critical thing too, so I'll put that in here. He's saying that has a base of 10. That helps. But warning, this 2 right here is kind of critical because we don't have a formula that says what the answer to this is yet. But if I move the 2, then I've got a formula that'll tell me the answer. Where could I move the 2? Aiden.
To be 4 squared.
Yep, it can go up there. And now, bases are the same. Answer's already there. The answer to this whole thing here is 4 squared is 16. And then it's log base 4 of 16. And from there, it ought to be really easy. 16 is really 4 squared. Answer's 2. You just covered a very important topic. Yes?
So if there's like a squared like that, what you're saying is the answer will just be the exponent?
This 2 in the front can always move up and be the exponent on the argument, yes.
And then that would be the answer most likely.
Yes, that usually means that that becomes the answer, not to the whole question,
Yeah.
but that became the answer to what's on the power of this 4. And then the answer to that was 4 squared, which, so the answer to this was really 16. It wasn't 2. Do you get what I mean?
Yeah.
Okay. So I just don't want like to say answer generically like, so that'll be the answer. 2 wasn't the answer, but 2 is the key to the problem. Okay. All right. Go ahead.
I don't understand how you got log 4 of 16.
Okay. So you get the log 4 is here, right?
Yeah.
Then maybe you don't get why that's a 16. That big red box is a 16 because these 2 bases are the same. And where'd that second base come from? It didn't have a base, so we knew it was base 10. Do you get if these 2 bases?
I don't get why the first 10 is a base. I don't get what that is.
Okay, so that's that. I'm going to give you a similar kind of question. If I said 8 to the power of log base 8 of 7, that is just a whole number that has an exponent of this. So in our problem, the 10 was a whole number that had an exponent with a log in it. And one of our patterns is, one of our like properties is that if these 2 numbers are the same, then the answer is that.
Oh.
So this 10 is like a whole number that has a power with a log in it. And so then you look and see if this number is the same as that number, and it was, and then the answer will be here, which was 16. That's why the whole big red thing was 16, and that's how I got the 16. Yes?
If it doesn't take like a crazy amount of time, could you explain like why that happened?
Sure, one last, let's say I had this to the log base 10 of 7. Why that is 7? Watch. Would you agree, earlier this hour I said you could always set it equal to x if you wanted to. Then, the most important thing about logs is being able to do a switch, where you switch it from one form to the other. And you might think this is a log, but it's not. This is not in log form, so you can put it in log form. And this is log base 10 of x equals log base 10 of 7. And then x is 7. So we've practiced a bunch of these things that are definitely things you'll see on your test. Question first, before I move on.
Can you go back?
All right. So we did a couple condenses earlier, but we didn't do one like that. Let everybody please try to condense this one. Okay. Condense it. Like I have to put those together? Well, the only way I can think of to put those together is if I could make them both be a log base 5. But that's impossible. I mean, the only way I can think of to make this a log base 5 is to say it's log base 5 of 5. And then to move this 3 up here, because you can do that, can't you? So then it'll be log base 5 of x minus log base 5 of 5 to the third, and then they have the same log base. Then I can say that they can be put together into a log base 5 of And this is a minus, which means it'll be a divide, x over 5 to the third. That involved making this have an extra log base 5 of 5 on it. Can you do that? Yep. I'd love to go back to elementary school and say, have the little kid write the answers 7 log base 5 of 5. You know, if the answer is 7, it's like 4 plus 3 is 7 log base 5 of 5. The teacher would be like, what the heck is that? Probably single-handedly qualify you for honors math the next year. And the teacher found out, technically he's right. What? Because what's log base 5 of 5? It's just 1. 7 times 1 is 7, right? So, got a younger brother or sister? If the problem is you throw that on the math test and the teacher would be like, wrong, because they don't have a clue what that would mean. No offense, just like usually nobody would catch what was going on there. So, okay. I do have a giant 1 somewhere. I don't know where I've put it. But by this point in pre-calc, we usually have found like 75 ways to write 1. And log base 8 of 8 would be one of them. There's a lot of ways to write 1.
So technically, there could be so many ways to write 1 because you have
Oh, yeah.
numbers.
Yeah,
You
you
could
could.
do 1 to the power of every
Yeah.
Yep.
real number.
So technically, we found over 75 ways to write 1.
1 to the x, where x is an element of the real numbers. That's 1. There's a million ways to write 1.
A million square root.
All right. You have plenty of problems to practice. This was a catch-up. Make sure you understand lots of little things day.
0.
New stuff tomorrow. That's all I got for you for today.